So what I'm going to present today is how we get to where Katrina was. Yeah. So everything looks perfect. The marketing team at Mac Venture says, yeah, we have this perfect alignment between TMS and fMRI. But we had a few challenges starting with in 2019, which I'm going to go through very quickly in a moment to introduce this interleaves, the so-called interleave TMS-fMRI. Just think about what interleave means. Is think about firing a machine gun through a propeller of an airplane. So this is what we're trying in a way to do here. And we not only that, we want to do it in less than 2 hours because we don't want to affect the schedule of the MRI. And thinking about how many people we need to use to get there, it's quite a challenge, you'll see. So starting with equipment challenges, yeah. So don't forget this is an electrical equipment in an MRI environment, so it has to be safe, both for the participant and for the MRI, and so interference is free. And then what the commercial solution that is presented here very nicely on the MacVenture website is basically just a mix and match approach. Yeah, so not necessarily an MR safe by design approach, right? So we identified at the beginning a few MR safety concerns to do with the neural navigation camera here, which contains some magnetic components. Also, there was things about the emergency stop. So the one provided, well, first of all, you had to have one for the MRI shown here and one for the TMS. So then if you imagine you only have two hands, where do you put your button box? I don't know. So obviously this was not fit for purpose because it was actually an electrical conductor. We needed something to mimic the Siemens approach, which is a pneumatic switch. So everything is now sorted. Okay, then the last point is a concern in terms of TMS induced electrical field that can cause extra heating. And then, as you can see here, we measured temperature on the surface of the TMS coil, and then you could see raise in temperature about 6 degrees, which is not, completely a safety because the TMS coil sits on top of the MRI coil. So yeah, you could say that's not a very big problem. And then just to give you a quick idea about the complexity of this setup, how many companies are connected. This might not work. It's gonna. Sorry about this. I don't know if this works. If not, it's not. Yeah. Okay. So I just made a quick map of all the. We're fine on mine. So this is a map of all the people involved. So companies in US, Australia, Europe, all these companies here are involved in producing this setup. And then if you put the time difference, if you put COVID restrictions and us trying to communicate with these people, yeah, you understand why it took so long to get where we are. Okay, so going back to this presentation, then we have identified also some interferences coming. So funny enough, going back to this camera, the manufacturer actually thought about MR safety, sort of projectile effects. So they tested things, they put stickers on the machine, but actually when they got to the point of interferences, they were, as you can see in this picture here, when the camera is off, it should look like this. When it was on, the amount of noise is, that makes is enormous. And then we managed to eventually, after many iterations with them, we managed to sort of reestablish a baseline, which is not far from the off when the camera is off. Yeah? And then also, what we realized is, you can actually see this interferences on the actual images. So it's not very clear here, but you have to believe me, there's some lines here that you won't be happy with. And then, So basically, as you see from you saw in Katrina's presentation, we don't really want to fire the TMS during the readout. First of all, because your images will look distorted, yeah, but also you can destroy the MRI coil or the receiver path, yeah. That's why. So hence my analogy with the machine gun and propeller, yeah. So we want to fire TMS in between those acquisitions. Other concerns, we realized we acquired this MRI head coil, which is suitable for TMS, which is like a big TMS, big MRI coil, which presented some peculiar features here. What you see here, this line is basically the actual body of the coil visible on MRI, which is not a big problem, but you never know when you see something which is not MRI signal, really. Also, this one is not suitable for multi-band. And the last concern we noticed was the cables. The operator has to do quite a fair amount of heavy lifting during the setup, and Katrina can tell you how her physical fitness increased during this. All right, so going now forward. So we finished all the nitty-gritties. We found solutions to everything. Look at this nice picture, marketing picture, right? Looks very nice. Everything's so easy, and then in reality, you end up with, we asked permission from this participant to be shown here. You cannot tell. I don't think you can tell who this person is, but it's quite a tight and messy environment. To be fair, we would like things to be a bit more smooth, yeah. But I consider this is probably the first setup in the world that is using all these components together to achieve this interleaved TMS-fMRI. But in terms of the team, it's a huge human resources, because we have 3 technical support guys, 2 radiographers, a physicist, about 3 researchers working, not every day, but for a fair amount of time since the end of 2019, during the pandemic, and till last summer when we started. So we started allocating a full day for scanning, and we had 2 radiographers and 2 researchers working. So we thought, well, 4 hours per slot, 3 slots to cover the 12-hour shift. But then, obviously, we thought, well, this is not going to work for everyone. We need to reduce this. So currently, we just run this TMS-fMRI as a normal, like a normal slot, 2 hours, basically. So this is just going through some more details about what we do. So we run a session on a Friday at the moment, where we acquire the MPRH, the structural scans that we need, the researchers use to localize the region of interest. They do some localizing fMRI tasks. And then on Tuesday, as it is at the moment, they will load this information on the neural navigation software and then start doing the motor threshold inside the MRI. So basically, you have to use the whole setup, which means you end up handling these cables that are more than 5 kilos heavy. And then once that is done, which can take, well, sometimes half an hour, sometimes a few seconds. It depends how good the person is or how good the researcher is finding this. And then you move on to positioning the participant on the table, making sure that everything, so you've given the earplugs for the noise, the emergency buzzer, which now, like I said, is just one. That is the MRI buzzer, which then splits into 2. And then making sure that at the end, so after you register your coil to the space of the participant, and then you register the TMS coil to the brain region, and then you finally wrap everything together in a sort of vacuum and then send them in for the scan. Okay, so I just prepared a quick promotional video. Yeah, so we are trying to sort of spin off. we are preparing the beds, leave it easy with them. Researchers are doing something well, finding the water pressure of the nitrogen state. It's just part of like the registering of the coil. Okay, so that was my quick promo. Now, what we learned from this experience over the 18 months, 2 years, from our point of view of radiographers, is the comfort of the participant, because you don't have that normal coil set up. You have everything is basically floating in the air. It's very hard to keep anything to support the head and neck of the participant, and also you have a problem if there's an emergency situation to quickly remove the participant from MRI, because there's so much equipment. So, and also if because we know there's some side effects with TMS, and then we had one situation when somebody was sick inside, and it was really interesting to just watch them like holding it in. Hold on a minute, we'll get you out. So, yeah, we don't think it was a TMS related incident. It was, the person was not feeling very well beforehand. But all these things we have to think about when we think about the future, how we can improve our setup to make it more suitable for this kind of emergency situation. In terms of researchers, what I could gather from their frustration sometimes is the participant keeping still during the acquisition, and also across the session. So they could start in a perfectly, we are happy with the localization, the TMS is spot on, but as we go along, we can see the head is actually moving away from the coil, which is again because there's nothing to really hold on. And then obviously if you spend an hour and a half doing the motor threshold and all these other things, you will ask them to go through an hour of fMRI now. They might just drop out in the middle. So it's that frustration that by reducing the preparation, we could just minimize this. Okay, so going beyond this setup, I said going beyond the 120 minutes, it's not like a target 120 minutes. That was just, you saw also from Katrina's presentation, we use at the moment surface coils. And the problem with surface coil is you have that first of all, you cannot cover the whole brain, so you have to put the coils exactly where your region of interest is. So that's why we acquire that coil there, which is supposed to, at least cover the whole brain. Unfortunately, it's not that great in terms of, you cannot do very well multiband. The signal is a bit, dodgy. It's not uniform. And then what I sort of propose is, going with something we know it works fine, the CMOS coils, and then just sort of do some adaptation of coils. So combining a head coil with a body coil you do for your chest imaging. So something like we did here, and then we got some more uniform signal, higher signal, I would say higher TSNR here. And then that could maybe potentially one day be of use. Also, the training to find the motor threshold, I said sometimes it can take half an hour. We just give up because there's literally too much to take. So that also can be improved, I guess, with the use of, some out of MRI sort of sessions. This was patient immobilization to guarantee that the TMS localization is maintained. So like I said, at the moment, we are just relying on the participant to really be like, grinding their teeth inside. And then also something to help will be a position aid for this motor threshold, so that the cables are, not in the way. You're not fatiguing. There's no fatigue in your hands after that. That all that work. So my last thing is just to thank you, the team, which, as you can see here, it's not just me or the researcher. Is a whole. This is just us at the CBU, but our discussions went beyond with groups in the companies or other partners. So thank you so much. Questions? I'm happy to